Now we'll look to Dr. Ronald Cohn for his update. Dr. Cohn has served as president and CEO of SickKids since 2019, where he has held a series of positions, including chief of the Division of Clinical and Metabolic Genetics, co-director of the Center for Genetic Medicine, and senior scientist at the SickKids Research Institute, chair in clinical and metabolic genetics, and chief of pediatrics at SickKids and chair of pediatrics at the University of Toronto. Dr. Cohn, thank you for joining us to provide an update on your current research into the combinatorial CRISPR-Cas9 mediated duplication removal and glucocorticoid treatment in humanized mouse model of DMD duplication. And there you are. Hello. Thank you for joining us.
Hello, and thank you for having me. And let me start by first saying thank you for your ongoing support of our work, and really congratulations to your 30th anniversary. I think you may not know how critical the support is that Defeat Duchenne has provided over the years, really allowing scientists to have creative ideas that are out of the box. And on behalf of my laboratory and many, many other scientists, I'm really very grateful. So
thank you so much for the kind words.
Let me tell you a little bit about our research. Can you see the slides okay?
Yes, we can. If you wanted to go in presentation mode, it would be full screen, but that's up to you. We can see it just fine.
No, let me try to make that happen. Is that better?
Looks great. Thank you.
Okay, thank you. Okay, so let's start by asking the question, why do we need a humanized mouse? We are really gearing what I hope will be the last step that we preclinically have to do before we can design a drug for a clinical trial. So in order to do this, we really felt like we need to create a mouse that has a human dystrophin gene. And the reason for this is if you see the mouse gene here in green and then compare the human dystrophin gene, you can see that there are actually some differences. And that's the reason why we have decided we need to create a humanized mouse as a model to try our CRISPR gene editing therapies that you just heard about from Dr. Tremblay. So interestingly enough, in 2008, somebody already developed a humanized mouse, and you can see that this mouse had a humanized gene, and we were quite excited, and we got this mouse to Toronto from the Netherlands from one of my colleagues, and we were trying to induce a duplication in this mouse, and it didn't work. And we had to do a lot of work to figure out why it didn't work. And interestingly enough, as you can see here, this mouse already had a duplication of the human dystrophin gene. So instead of creating a mouse with just one copy of the human dystrophin gene, it had two. So we were thinking, okay, so why don't we use CRISPR, which is kind of the genetic surgery method that you can use, to cut out the duplicated version of the human dystrophin gene, and then we have our mouse. Well, it turned out we did this experiment, and then we ended up with a flip. Instead of getting rid of this, we actually had a flip, and we had still two copies of the human dystrophin gene. So we had to go through another set of experiments where we tried to cut out pretty much the duplicated version of these two genes right here, and then create a mouse that finally had one dystrophin human gene. So what I'm telling you here in 2 minutes was work of about 8-9 months at least. But finally we have this mouse, and we have now created a mouse with a duplication of exon 44, which we are using for our experiments that you are funding. And the experiments we are doing are really different than many of the experiments that are currently being done, in as such that we are not just doing genome editing to cut out the duplication, which you have seen we can do, but we are going to do it in combination with either steroids or with vamorolone, because every Duchenne patient is either taking steroids or is taking vamorolone. And in order to really test the efficacy of what we are trying to do and what we want to bring to clinic, we actually have to test it in a mouse to see how steroids or vamorolone have potentially an impact on the genome editing therapy. So this is what we are currently doing, and this is what you are funding. And I will tell you that I'm very optimistic that at the end of this period, we'll be ready to have a drug that can go into clinical trial for patients, not just with the duplication of exon 44, but for many other duplications. We have many, many other models of duplications in the laboratory. And hopefully next time I come, I can show you some exciting mouse data. So thank you.
Well, thank you. I think that was very exciting. So I can only imagine if you think that wasn't exciting, what will come next. So thank you for joining us.